Okay, so we're going to look at simultaneous equations. So we've obviously done simultaneous equations before. Now, when we would have done simultaneous equations before, it would have been for equations where maybe we had, say, 2x plus 3y equals something, and then maybe another amount of x and another amount of y equals something else. And we would solve accordingly, and we would eliminate one variable, and we would find the answer for that one variable that's left, and we'd use that to find the other variable. So simultaneous equations, we already know, kind of come in when we have two unknowns, okay, or three. As we saw in the tripletaneous ones, we can have three variables as well. But generally, we're going to say simultaneous equations kind of spring to mind when we're talking about things that have two variables involved. So that's kind of a key aspect, I suppose, of the questions. Now, the other parts we need to know with simultaneous equations are the types of equations we could have, and particularly here where we're looking at what we call one linear and one non-linear. So remembering that a linear equation, so obviously linear comes from line, or line I suppose comes from linear, is one where the highest power of the variable is 1. So that's equations where we might have just 4x plus 7 equals something, okay? And I suppose we would have y in it as well. So maybe y equals 4x plus 7, for example. That's a linear equation. Highest power of the variable x is just 1. A non-linear equation will have x squareds, y squareds, xy. So we're going to see loads of different variations of these. So we could have x squared plus y squared equals 7xy, for example. And that's a non-linear equation because we have squareds. Okay, we're no longer just in the linear plane, the x's and the y's to the power of 1. Once we go higher than that, we're looking at non-linear equations. And when we're solving a set of equations where one is linear and one is non-linear, we use substitution. Now, we should remember from doing these equations originally when we did our simultaneous equations, one of our options always is substitution. So we never have to solve by elimination, which is what we did earlier with maybe eliminating one of the variables and so on and so forth. You can always solve it doing substitution. So it's just about picking kind of which works for you, whereas these ones here, we have to use substitution. There's no way we can kind of eliminate the variables otherwise. So we're going to be substituting. So the steps we're following, we rewrite the linear equation. Now that's important. We rewrite the equation where we have the best powers. Okay, it's easier to rewrite one where the powers are 1. So we rewrite the linear equation in terms of one variable. So one variable is the subject. So the example I suppose there is like we have in that kind of that I wrote at the top there, the y equals 4x plus 7. That's just one variable, one equation written in terms of one variable. So y is equal to something. That's what we're aiming for. We substitute that equation into the other one. So for this one here, for example, anywhere we'd have y, we would fill that one in. Okay, so we could fill it in for the y squared, we would fill it in for the 7xy. Once we've that done, now we can solve that equation because it will only have one variable, so we can solve it as normal. You can probably guess by looking at it, but a lot of the time you're going to end up with a quadratic. I would say all of the time you're going to end up with a quadratic of some sort. It could be difference of two squares either, I suppose. And then using this result, we find the value of the other variable. Okay, so we have to remember to go back to find the other variable. Now what we should have really is a set of points. Okay, we should have a set of points, so 2 x's and 2 y's. And where we usually find with our simultaneous equations, when we would have done these before, this point here would have been the point of intersection of the two lines. So say I gave you two lines, 7x plus 3, and I gave you another line over here, I suppose, say we said this was minus 2x plus 2. If I wanted you to find the point of intersection, we could do that using simultaneous equations. What this type of simultaneous equation gives us is it gives us the point of intersection, so same as that, between a line and a curve. Okay, and you can see there as well that I've put in points of intersection because we can have different scenarios for how a line and a curve can intersect. And we're going to look at that in a little second as well, just to get that kind of into our heads. But first of all, let's just look at an example. Let's put some of these steps together and put some of these steps into practice. So we have a squared minus ab plus b squared equals 3, and I have a plus 2b plus 1 equals 0. So immediately looking at that, I can identify that this is my nonlinear, and that's fairly clear to me because it has squareds in the powers, which I suppose by process of elimination makes this linear, but also we should know it's linear because the highest power of the variables is just 1. So what I'm going to do is I'm going to take that linear example, the a plus 2b plus 1 equals 0, and I'm going to rewrite that in terms of one variable. So I'm going to rewrite it in terms of b. So I'm going to rewrite a being equal to minus 2b minus 1. Okay, and let's highlight that there. That's important. So we've now got a new expression for A in terms of B. So in terms of B, A is minus 2B minus 1. Okay, let me just say, I might make that pen a bit thinner. It's a little bit harder to read there. So let's just go now with the initial equation. So A squared minus AB plus B squared is equal to 3. So what I'm going to do here is I'm going to take the equation that I have over here in terms of A, and anywhere that I see A, I'm going to fill it in to this equation on the left hand side. So we can see straight away minus 2b minus 1 squared minus by minus 2b minus 1, using our brackets here to make sure, particularly with the signs in this equation. And I'm just going to highlight those in so you can see exactly there where we've substituted those in. So anywhere that we had the minus, the A, we filled in minus 2b minus 1. So following that through then, that's going to give me 4b squared plus 4b plus 1. Then this part here, multiplying that out, is going to give me plus 2b squared plus b. Okay, and we lastly have the b squared at the end there, and again all equal to 3. So bringing all of that together, I get 6b squared, or sorry, 7b squared, not forgetting the b squared at the end there. So 7b squared plus 5b, and bringing the 3 across, I get minus 2 is equal to 0. Okay, 7b squared plus 5b minus 2 is equal to 0. If I factorize that there, that's going to give me 7b minus 2 and b plus 1 equals 0, which gives me that b is equal to 2 over 7, or b is equal to minus 1. Okay, so again, as expected, 2 answers for b this time. We're used to maybe just having 1. Now we're going to have 2 in these questions here. Now what I need to do is go back to my original equation here, which was a is equal to minus 2b minus 1, and I take my 2 options for b. So let's start off with b being 2 over 7. That means a is minus 2 times minus 2 over 7 minus 1, which is of course 4 over 7 minus 1, which is going to give me an answer of minus 4 over 7 minus 1. Let me type this one in here. Minus 1, which is going to give me minus 3 over 7. Sorry, I've made a mistake there. That should be a plus 2 over 7 in the middle. Yes, that makes more sense. So minus 4 over 7, yes, that makes more sense. Minus 11 over 7. Okay, minus 11 over 7 there. And then this one here, b being minus 1. So this time, yes, we are going to have the negative sign inside there. So we get 2 minus 1, which of course just gives me 1. So filling in my 2 points there, if we put a first maybe, we will have minus 11 over 7, 2 over 7, and we will have 1 minus 1 as my 2 points of intersection for those 2 curves. Okay, so as we said at the start, we should have 2 points of intersection for us to work with there, compared to maybe like the one that we would have had originally in some of the other equations we would have done. So I said we would come back to this idea of what it means. Okay, so it's all well and good knowing how to do it. We have to also have a little bit of an understanding of what it all means as well. So when we're looking at simultaneous equations for a linear and a nonlinear, what it means is we're looking at where does the linear equation intersect with the nonlinear equation. And a linear equation can intersect either at 2 points, like we have here, so 2 points of intersection, so it crosses over the curve completely. It could intersect at 1 point, which would be like this point here, and we call that a tangent point. So a tangent is just where a line touches a curve just at 1 point. Or it may not intersect at all. So for example, in this one on the left hand side here, we can see that there's actually no point of intersection between that curve and that line. So sometimes they may phrase the question in that way. They may ask you to show that this line and this curve do not intersect, and you can do it by using this method here, using a simultaneous equation, but you will get a solution that doesn't work out. Okay, you'll get it that there is no intersection, there's no value for your answer. If they intersect at 1 point only, it's said to be a tangent, as we said there. So that's the middle example. Okay. So this is kind of what I was talking about there with that last example. So we're being asked here now just to investigate. They're not telling us that they definitely do or do not intersect, but just investigate whether they do or not. So again, as we did with the last one, let's just take this equation. First of all, I'm going to rewrite it. So again, I'm going to rewrite it with x is equal to 1 minus 3y. I'm then going to fill that into x squared plus 6xy plus y squared equals 3. So let me just highlight this here. So again, anywhere I see x, I'm going to fill in 1 minus 3y. And y squared at the end. Okay, same as before, and let's just finish that off there. So just so we can see where we've substituted that in, multiplying out my bracket, 1 minus 6y plus 9y squared plus 6 minus 18, sorry, multiply out that bracket completely, plus 6y minus 18y squared plus y squared equals to 3. Okay, simplifying all this down, I suppose, as best we can, we're going to get minus 8y squared minus 2 is equal to 0. So we can divide across there by minus 2, I suppose, and get 4y squared plus 1 is equal to 0. Okay, immediately I'm starting to see some issues here because I've gotten to a point where there's not any real substitution or factorization, that I can do here. It's not really a quadratic. It looks like it could have been like a difference of 2 squares, but we don't have a minus in between them, so it's not a difference of 2 squares. So really all I can do at this point is attempt to solve. So let's bring the minus 1 to one side. Let's divide by 4. Again, I'm seeing some issues here. My next step would be to do a square root. Square root of minus 1 over 4, and we should hopefully recognize that as being a complex number. Okay, we should hopefully recognize that as being a complex number. And what I mean by that is it's not real. If you type that into your calculator, we get a solution that doesn't work. Okay, we get a solution that doesn't work out for us. We can't have the square root of a negative number. They're giving it to us here as I, which is a complex number. Your own calculator might just give you an error trying to do the square root of a negative number. So this is a complex number. It's not real, so we have no real solutions. So therefore we can say there are no real solutions, and therefore that means no points of intersection. So therefore they do not intersect. Okay, so again, just showing that it's not alone enough to just know how to do it. You have to also kind of understand what it is that you're doing and what does it mean in terms of the question that you're looking at. So let's just get into now this exam style of questions here. So we're starting off with an exam style word question. And again, just breaking that idea of what does it all mean to some extent here. So we're just kind of working with just making sure that you can kind of explain away the questions. So the path of a ship is given by a particular equation. So it's a linear equation here. The boundary of Irish waters is given by this equation. Okay, so obviously a different equation here. This is my nonlinear equation. Let's give it a nice blue for the water. Find the 2 points, so 2 points at which the ship passes into Irish waters. Now, the reason I know immediately that this would be a simultaneous equation is primarily the fact that there are 2 variables. So 2 variables suggest to me simultaneous, and we now know with simultaneous equations, it's not enough to just say, oh, it's the ones where I stack them up and try and remove one of the variables. I also have the nonlinear case here as well. So we start off by taking my original variable here, 3x plus 5y equals 5. We're just going to try and rewrite it in terms of one of the variables. It doesn't actually matter which of the variables we decide to go with, to be quite honest. So let's just rewrite it in terms of x. That's going to give me 5 minus 5y over 3. 5 minus 5y over 3. Okay, again, it doesn't particularly matter which of them we go for. If I look at the question, okay, from looking at the question there, so that's why I should look at the question first. From looking at the question, actually having just done that, I can kind of see that maybe x isn't the one to go for. And the reason that I think that is, I can see there is an x here and there's also an x here. So if I rewrite it in terms of x, I need to sub into 2 places. Whereas if we see alternatively, if I rewrite y and try and get rid of y, I only have to sub that into 1 place. So that probably is the best thing for me to do. So let's just rewrite that part there. Get rid of the orange. So let's go again. So this time I'm going to rewrite it in terms of y. So 5 minus 3x over 5. Okay, we're rewriting this now into the original equation, or the nonlinear equation here. Just highlight this part here for myself. So I'm going to be filling that in anywhere that I see y, which of course, as we know by design, is actually only in one place. Minus 10x minus 9 equals 0. Okay, so let's continue. Let's multiply out x squared plus 25 minus 30x plus 9x squared all over 25 minus 10x minus 9 equals 0. Okay, so multiplying out our initial bracket there, I suppose, as best we can. What we'll do now is we'll multiply across by 25, just to try and simplify everything down. So 25x squared plus 25 minus 30x plus 9x squared minus 250x minus, let me see, 9 times 25 gives me what? 225. Minus 225. Okay, minus 225 equals to 0. So now we're just going to simplify everything down. So I'm getting 34x squared. In terms of my x's, I'm getting minus 280x. And I'm getting minus 200 is equal to 0. Now I can divide that by 2. I get 17x squared, 140x, and 100 here. Now, looking at this one, I'm going to save ourselves some time. We're going to go straight to minus b, okay? Particularly, I suppose, because the numbers are quite big. That's maybe one sign that we might go straight to minus b. So let's just fill everything in. So minus 140. So that's going to give me plus 140 here. Plus or minus the square root of 140 squared minus 4 times 17 times minus 100 all over 2 times 17. All over 2 times 17. Okay, and if we solve that out, we're going to get 2 decimal answers this time, but that's okay. We're allowed to have decimals. We're not going to go crazy. We're allowed to have some decimals. It's always nice to have just nice whole number answers, but I have 2 decimal answers. If I round them to 3 decimal places, this is what I'm going to end up with here. So 8.896 and minus 0.661. You could leave it in terms of your surd form if you want, but again, it doesn't even round to a particularly nice fraction either. So we'll just go to our decimal points. We've got our 2 x values. We're going to use that now to find the 2 y values that we have. So starting off or subbing in each of those x values in for y using my fraction over here, I get y is equal to 5 minus 3 times, let's do the 8.896 first, all over 5, and multiplying that out, I'm going to get that y is equal to, let me see, I'm just going to check my workings here, 3376. Okay, so we could round that up to maybe 3 decimal places as we've done with the x's, so 338. And for my other version for x then, the minus 0.661, again all over 5, I'm going to get an answer of 1.397. So my 2 points here are 8.896 minus 4.338 and minus 0.661, 1.397. Now I know absolutely nothing about sailing, but let's just say that those are kind of reasonable answers. I mean, at the end of the day, it's just a word problem. Okay, they're just trying to put some words onto your maths questions to make you think about it. But just kind of thinking about what that means, it's the 2 points that my ship crosses into Irish waters. So we're presuming the Irish waters border has some sort of non-linear path. That equation to me actually kind of looks like it's probably like a circle of some form. So obviously that's not something we have done yet, but it kind of looks to me like it probably is some sort of circular shape, which would kind of fit in with what we might expect the border of Irish waters to be. So the ship obviously is just coming kind of close to and then going out of the waters again. So we have 2 points of intersection. Okay, so let's see, we have 2 more kind of more standard questions to look at here, I suppose, where it's just solve the simultaneous equations. We're going to solve them exactly the same way as we've done with that one, exactly the same way as we've done with the examples here. So we start by taking our linear option here, the 2x plus 3y equals minus 1. We're just going to rewrite our question. We look at our question and see, is there any letter that's particularly easier? There doesn't seem to be. So if we do 3y equals minus 1 minus 2x, so y is minus 1 minus 2x over 3. Let's just fill that in now to the equation anywhere that we see y. But as I say, nowhere that seemed particularly easier. I suppose the only thing we maybe could have avoided by doing x was having to multiply this by 2. But let's just highlight this here again, just to help me see exactly what I'm subbing in, to keep everything straight for myself. So let's just bring the x inside the bracket here. So minus 1 minus 2x squared over 3. Sorry, that should be minus 1x. So minus x minus 2x squared all over 3 plus, and let's do the same here, minus 2 minus, or sorry, I need to square that bracket first. Jumping ahead of myself here. I want to get that 2 multiplied. Let's square this bracket first. So 1 plus 4x plus 4x squared all over 9. 1 plus 4x squared all over 9. Okay, let's just see. I'm going to multiply across here by 9. At this point, I'm going to multiply across by 9 to get rid of that fraction. So 9x squared. This one's going to have to be multiplied by 3 on account of the 3 on the bottom. And 2 plus 8x plus 8x squared equals 36. Let's just try and simplify everything down here as best we can. Minus 6, or sorry, not minus 6x, minus 3x minus 6x squared plus 2 plus 8x plus 8x squared equals 36. Okay, so again, we're going to bring everything together as best we can and try and simplify everything down. So I'm getting 11x squared in total. In terms of my x's, I'm getting plus 5x. And in terms of my numbers, I'm going to get minus 34 when I bring this over to the other side here. Okay, so factorizing that gives me 11x minus 17. And it gives me x plus 2. So we get x is equal to 17 over 11, and x is equal to minus 2. Now that I've got my values for x, I just need to use my y formula here and just fill those values in to that formula to get my answers for y. So let's just fill that in here. So minus 1 minus 2 times 17 over 11. Always good to show that you've written it out first and then maybe type it into your calculator, and not just typing it in without showing what you're doing. Show the examiner or show me that you're kind of following the steps here. Minus 2, 3. So y is, let me see, I can kind of see that one working out already. I've got rid of it. Okay, and we just get an answer of 1. So my 2 points there, if I bring them together, 17 over 11 minus 15 over 11 and minus 2, 1. Bring it all together there. It's always no harm to just write out those points at the end. Again, just kind of showing off or showcasing your answers there. So we've one last question to do, same as before. We're going to start by rewriting our linear one here. Again, I think I'm going to do again, it's just a matter of deciding here, really, x or y. I was going to jump straight in with x, but as before, y only appears once, so why give myself extra work to do? X plus 8 equals to y, or y equals to x plus 8. So again, anywhere I see y, I'm going to fill that in. X plus 8 equals 0. Okay, nice straightforward looking one here, to be quite honest. Let's mark that in for ourselves. X squared plus 8x equals 0. So we get 2x squared plus 8x equals 0. Okay, 2x squared plus 8x. Sorry, there's a plus 8 at the end there. The end of my question. Better not forget it. There we go. That looks a bit more like something we'll actually have to do. X squared plus 4x plus 4. And x squared plus 4x plus 4 gives us a nice solution of x plus 2, x plus 2. It's just a perfect square. So we get that x is just equal to minus 2. Okay, we just get that x is just equal to minus 2. And we can sub that into our answers there. So we get that x is equal to minus 2. And I can fill that in to get my value for y. It's minus 2 plus 8. So I get that y is equal to 6. So my two answers, x is equal to minus 2, y is equal to 6. So that might be an example where my linear graph only intersects my quadratic at one point, or my curve at one point. So it's a tangent point to the curve there. Okay, so just being careful the whole way through these questions that we're definitely, solving out all those points, that we're finding out all those values correctly, that we're definitely going back and finding the y values. And then as we've seen there, just making sure as well that have some idea of what it all means. Okay, what does it mean for the curve to have 2 points of intersection, 1 point of intersection, no point of intersection? And are we confident that we could find those if need be?